Hi everyone, today's lesson is on unit conversion. Unit conversion is essentially when we convert the value of a variable into different but equivalent units. So some of you may feel comfortable doing this already on your own, and for some of you this might be something you've struggled with in previous science and math classes. In fact, many adults can find this to be really challenging. But you're in luck because today I'm going to give you a step-by-step way to convert from one unit to another fairly simply. So even if you have your own method of doing unit conversions, and there's definitely more than one way to do it, for the purposes of this lesson, I strongly encourage you to try my way, even if it feels slower and has more steps involved, because this skill is critical for being successful in this class and in your future science classes, and actually even throughout your life. It's important that we get the steps done correctly, and so please try it my way. So before we get started, let's go through some background information you need to know. So as we talked about in class, all numbers need some sort of units on them. So if you don't put any units on a value, it could represent anything. And multiplying something by 1 never changes its value. So for example, 3 times 1 is still 3, 5 times 1 is still 5. Even a letter like H times 1 is still H, and an apple times 1 is still an apple. There are also lots of ways to write the number 1. For example, 5 over 5 equals 1, and you could write 1 in a different way by saying 2 plus 1 divided by 3 also equals 1, because 2 plus 1 is 3. 3 divided by 3 is still 1. So if something is equivalent to something else, it means that it is equal to something else. When we use the term an equivalency is a nifty way to write the number 1 using a fact about two objects with different units but have the same value. For example, 1 year is the same as 12 months. So 1 year divided by 12 months is still 1. You can flip it around, and 12 months and 1 year are still equal. So 12 months divided by 1 year still equals 1. So there's really no difference between 1 year over 12 months equaling 1 and 5 over 5 equaling 1. They're what we call an equivalency. So we also can call these things conversion factors. It's just another term that we use to indicate that it's a phrase that equals 1. And when we put these ones into math problems, it allows us to convert between different units. So if I give you a problem like how many days are in 5 years, lots of you will probably get out a phone or calculator and you'll just type in some numbers real quick and maybe shout out an answer. So you may get the right number. You probably did 365 times 5, but in the process you violated several rules of math. And so we're going to back up here and do this problem in a much longer, more explicit way that will help you to break down the other problems that you encounter in the future that could be much more complicated. So our first step in solving a problem or converting units would be to write down the units you're starting with on the left-hand side of your page and the units you want to end up with on the right. And you're going to create a path along the way that you'll follow. So we're starting with years on the left-hand side, and we want to get to days on the right. So your second step is to try and think of a conversion factor, or one of these equivalencies that equals 1, that connects the starting and ending units. So we're starting with years, we're trying to get to days, and you may know that 1 year is equivalent to 365 days. So that's our conversion factor that we're going to use. Alternatively, if you don't know that there are 365 days in a year, you may be able to come up with more than one of these conversion factors that will allow you to connect the start with the end using the factors you do know. For example, you may know that 1 year is equal to 12 months, that 1 month is equal to approximately 4 weeks, and that 1 week is equal to 7 days. So you can use these different conversion factors to make your way from years all the way down the path to days. So step 3 is we're going to set up the problem by writing our starting value and unit over on the left-hand side. Then we're going to multiply it by the ones that we've made out of our conversion factors, and we're going to do this as many times as we need in order to get to our final unit that we want, which in this case is days. So our first conversion factor we're going to use is that 1 year is equal to 12 months. So this is our equivalency. And it's important that you lay out the conversion factor the correct way, having the unit you want to cancel be on the bottom. So in this case we want years on the bottom, so we'll cancel out with the years that are next to the 5. And we want to keep that in mind during the whole problem as we go along. So our next conversion factor is that 1 month is equal to 4 weeks, and 1 week is equal to 7 days. Now, you may be looking at this as a math problem and going, I don't know what to do with all these numbers and words, but it's actually a lot simpler than it looks, because the properties of multiplication say that we can actually multiply everything we have across the top, put a line down, and then multiply everything across the bottom. So you're going to end up with something that looks like this. So across the top we have 5 years times 12 months times 4 weeks times 7 days, all over 1 year times 1 month times 1 week. Things can now cancel out because we have, for example, years on the top and years on the bottom. So we're done with years. We can cancel out months on top, months on bottom. We can cancel out weeks on top and weeks on bottom, and we are just left with the unit that we want, which is days. So now we can actually do the math, and 5 times 12 times 4 times 7, all divided by 1 times 1 times 1, you end up with 1,680 days. Okay, so what did we do? Well, we solved the problem using conversion factors, and it took extra steps than you probably would have done if you were just doing it quickly on your own with your calculator. But these steps that we took will help you with more complicated problems in the future. And instead of taking the easy way out, we should try and stick to this method for part of our class. And I'll show you how this slow, clunky method will actually help you in additional problems coming up shortly.